Okay, good afternoon. Today I'm going to perform a demo about simple and fractional distillation. The first thing, I'm going to show you all what we need. So the first thing you do, you get two vials. One vial is labeled S1, which means simple distillation, and the other vial is labeled F1, which means fractional distillation. And then you need a beaker. The beaker, that's for the reservoir. You are going to collect the drops, the later. Then you need a 10 milliliter round bottom flask.
10 milliliter? Yeah.
10 milliliter round bottom flask. You need a micro distilling head. That's a micro distilling head.
Okay.
You need a micro air condenser.
Micro air condenser, yeah, let's see.
Micro air condenser.
Yeah.
You need a thermometer. There's a thermometer here.
Okay. Cool.
And a thermometer adapter. Thermometer adapter.
Thermometer adapter.
Yeah.
Cool.
Okay. Now, I'm going to show you the setting first. You have a sun bath, which you see here. That's a sun bath. And that's a jack.
It's a jack, yeah.
Yeah. So, first thing you do, so you clamp the micro air condenser. So be careful not to force here. It has to be gently with finesse. If you go with force, you are going to break that.
Okay.
You don't want to do that.
Don't break it.
Yeah. So now put the 10 milliliter round bottom flask.
Yep.
Distilling head here.
Cool.
Yeah. And then the thermometer adapter.
Okay, so you have
That's the setting.
the flask, got the condenser, you have the top thermometer adapter, and then you have the
Thermometer adapter is
thermometers
that. That's
attached
distilling head, yeah.
to the thermometer adapter. Okay, and then you'll put something there, I imagine.
That's the distilling head.
Distilling head,
yeah,
yep.
micro distilling head.
Yep. Okay.
Micro
Cool.
air condenser and 10 milliliter round bottom flask.
And everything's screwed in so it doesn't fall out.
Yeah, yeah.
So that's screwed in so the
Yeah.
flask doesn't just plop off.
Yes.
And all these are just screwed in and attached. Yeah. Okay, cool.
So now we are going to fill that with a mixture of 50% ethyl acetate, ethyl propionate.
So ethyl acetate, ethyl propionate.
But we need to do that in the hood.
Okay. Cool.
Yeah. That's enough. Once it's done, you close it.
Okay, so
Okay.
how much did he get? About 7 mils?
7 milliliter.
7 milliliters
Yeah.
of ethyl acetate,
7 milliliter
ethyl...
of a mixture of 7 milliliter of a mixture of ethyl acetate, ethyl propionate, which you can see here.
So let's read that. Ethyl acetate, ethyl propionate, 50-50, roughly 7 milliliters.
7 milliliters, yes. that's here. We still have to go to the hood.
Alright, so it's in the round bottom, right there, the 1-to-1 mixture of those two chemicals.
Yeah. And you need to go back to the hood with the S1.
S1.
Vial label S1.
Yep.
Yeah.
S1.
This one there. So I'm going to add 1 milliliter of diethyl.
So it's diethyl ether.
Diethyl, yeah.
Or it's labeled on there ethyl ether.
Yeah.
But that's really there's two of them, diethyl ether. Okay. Yeah.
So the plumage, I open the S1 and I add 1 milliliter.
Okay, let's see, 1 milliliter. So you're at 1 milliliter
Of diethyl.
diethyl ether.
And I need to cover that like that.
Cover it so it doesn't evaporate.
Yeah, because if it's diethyl does evaporate very fast, and
So
once it's happened, it does build peroxide, and peroxide are very explosive.
So diethyl ether, it does evaporate at 35-degree boiling point.
Yeah.
So good.
So. Now to avoid the bubbling, I'm going to add 1 boiling stone.
So they're boiling stones,
Yeah.
little rocky
Yeah,
things.
because it's too small,
Yeah.
we call that the boiling chips chemistry.
Yeah.
Yeah.
Boiling chip.
Yeah.
Okay. And so that's still your mixture of ethyl acetate and ethyl propionate,
Yeah.
the initial one. Okay.
On
And
my
you're
copper jack.
jacking up the heat bath, the sand bath.
Okay. So first we plug that to a regulator.
Plug the sand bath into the regulator. Okay, plug
Okay.
in.
And start to roll.
Power.
Yeah. And I go until 5.
5.
Yeah.
Let's check it. Number 5 is the magic setting. Okay.
So
And you're gonna dug in there a little bit. You
So-
put some sand on the sides
yeah.
there.
so now,
Sand is slowly heating up.
yeah. Now that's where it's here is the reservoir. Okay, and I will speak
The,
about that.
the beaker, yeah.
Yeah, a small beaker.
Yeah.
So first you take the S1 vial, and you open it. You collect the first drop. You close it, and your lab partner gives you the beaker, and you start collecting deras. 1 dera corresponds to 2 drops.
1 data point will be 2 drops.
2 drops, yeah, and you collect 8 deras.
8 data points.
Yeah,
Okay, so it's 8 times 2 is 16?
yeah,
Okay. Alright,
okay.
cool.
And then
So right now there's ether in there?
it's diethyl in there.
Yeah, okay. Okay, so we're waiting for it to start boiling, yeah?
Yeah. want to say something.
Okay, one second. So it's not boiling yet.
Yeah.
There's no boiling. It's just heating.
Yeah.
Slowly heating. All right.
Yeah.
What are you gonna say?
So I remind you that when you speak about distillation, that means boiling, vaporizing, condensing, and collecting. I repeat, boiling.
What's the first word?
Boiling. To boil.
Boiling.
Boiling, yeah.
Boiling. All right. Boiling. Got it.
Boiling, so it's hard to speak with,
Yeah.
this guy.
Yeah. You're boiling it up. You're heating it up.
Yeah.
Boiling.
Vaporizing.
Evaporating. Yeah.
Condensing.
Condensing. Yeah.
Collecting.
And then collecting. So
Yeah.
it'll boil and then evaporate into the vapor, and then
You will see what condensation.
condensation,
Yeah.
and then collection.
Yeah. You are going to. Yeah, I just have to
Got
take
it,
my
I'm
mask
sure,
out.
yeah.
So as I said, you collect the first
Yeah.
drop.
Okay, and
But
we're waiting. It's gonna take a while.
Yeah, it's take a while. Here you have diacetyl, or you cannot just open that now.
Yeah.
You need first to see the boiling,
Yep.
and you will see the evaporation here.
Yep.
You see the condensing, and you are going to collect.
Okay. All right. So,
Okay.
all right.
Ethyl acetate.
So that's ethyl acetate.
Acetate.
It's one of the mixture components. It's
Yeah.
they don't know it yet, but they'll learn
And the
soon.
boiling point.
Yeah. .77 degrees Celsius.
Yeah.
Yeah. And then ethyl propionate. And you'd think that since it's a little bit larger, it'd have a slightly higher boiling point. So it's 99 degrees Celsius.
Yes.
99. It goes from 77 to 99, and they're learning in the class in the lecture right now that this thing is called an ester.
Yeah.
So this is the C double bond O, oxygen, carbon, and it's called an ester. So this is a ester functional group.
So you have that here.
Ester functional group in both of them.
And you also have that over here.
Okay.
The same thing.
Ester, yeah. Cool. And then the other molecule.
Because sometimes we ask questions.
Yeah.
Sometimes we can.
Cool. And then the other molecule is ether, right? It's, all right. So then the other molecule is called diethyl ether. It's CH3, CH2, oxygen, CH2, CH3, and that's what you're using as a solvent or whatever to when the esters are collected, you put them in the diethyl ether.
Yes.
We can tend to kind of to analyze it. You need a solvent.
Yes.
And that's for the gas chromatography.
Yes.
And diethyl ether is the solvent you use. And ether happens to also be a functional group, which is the carbon, oxygen, carbon. ROR. That's the ether functional group as well.
Yeah.
Yeah. All right, so we're back at the experiment, and it's still heating up. It takes, what, 15 minutes or 10 minutes?
Yeah, it depends, yeah.
About 10 minutes. It's still heating up. It's getting hot. The sand's getting hot. Is it boiling yet? It does not seem like it's...
It touch,
a little bit.
yeah, it doesn't boil yet.
Not yet. It's going to take about 10 minutes. We'll probably cut the video a little bit while it's heating up.
Yeah.
And then this should slowly get hot too.
Mm-hmm.
Oops. So the air condenser is warming. It's warming, and then eventually we'll see some drops or something there, and then eventually it'll drip out and we'll collect it. Yeah. From the thermometer adapter. Okay, so we'll just come back in a few minutes.
Yeah.
So little status report. It's been about 5 minutes, and the solvent's starting to boil a little bit. We increased the temperature a bit on the regulator.
Yeah.
But you can kind of see there's a little bit of a vapor front. Like
you can start to see that.
So right about there's a little bit of a, it looks like the liquid's slowly climbing.
Can see that,
So it's got a little bit more to go before it gets up, and then we can start collecting it. But it feels warm.
Yeah, it starts to boil. As you see, it starts to boil here.
It's boiling. It just takes a while.
One at 77 degrees Celsius. That's already high.
Okay. And then we have the other one that's going to be a little
99 degrees Celsius.
90 degrees Celsius. Okay. So I'm going to pause this and come back in a few minutes.
Yeah. So we need some ice.
Get some ice.
Yeah.
All right. Let's go to the ice. Take a look. It is boiling now, but it's still climbing up. Zoom in there. You can see it's definitely boiling. That's good. But we're going to get a little bit of ice.
Here is the ice machine here. We're going to get the ice, the some. That's enough.
Got some ice?
Yeah.
Alright, so we're back. We got our ice. And this is still boiling up. It's boiling. Let's feel the temperature a bit. So, definitely warm. A little cooler up top. It's coming though. Alright, so we're still waiting. We'll probably pause it a couple more minutes while it climbs up, and the warmth should go from the bottom all the way to the top. That's not quite there yet, but it's getting there. So yeah, we're about 10-15 minutes in. There's a lot of boiling, and it's a little hard to see here, but there's definitely the solvents traveling up, and you can feel it. It's hot. It's hot now.
Yeah.
And it's up there, and we're about to start ready to start dripping, and we're going to collect it into the vial, but we're waiting on it. So
it's still at 20 here.
Yeah, it should be climbing up to about 70 something. Yeah. So it's coming. I think the big challenge right now is that it's just the air is cool up top, and it's keeping it kind of cool. So it just takes a while to get all the vapor all the way up. What do you got there?
Yeah, you can't stop.
All right, and because it's a little slow for the vapors to climb up, we've kind of wrapped it around with glass wool. So we have tons of this glass wool stuff, and it's just a thermal insulator, and it just keeps the surface hot. And we also, I think we're also just keeping the sand around the flask. So there's a lot of sand there, hot sand, to keep the heat coming in. And it's gonna hopefully start dripping pretty soon, now that we're holding the
it's going up,
glass wool. Temperature's going up?
Yeah.
Okay, so what's the temperature at right now?
It's 40. 50.
40, 50.
60.
60. It's climbing, we see it. It's getting up to 70. A little hard to see.
Yeah,
there.
that's the first drop coming.
You got to drop out?
Yeah, first drop.
One sec. So you put a drop into the vial.
Yeah. And now I'm just going to collect the data.
Yep. So I'll cap the vial.
Got that. One.
Now you're collecting into the beaker, yeah?
Yeah.
It's dripping.
Two.
Let me see.
That's 73 degrees Celsius.
73 degrees Celsius on the thermometer.
One. Two. Secondera is 74.
So it went from 73 for the first 2 drops, 74 for the second 2 drops.
Yeah. One. Two. 75.
So the third data point is 75 degrees Celsius. 75.
Yeah. $77.
So next one is 77.
Yeah.
Fourth data point is 77 degrees Celsius.
Two. 78.
78 is the fifth data point.
Yeah.
78.
One. Two. 79.
79
Yeah.
is the sixth data point.
Yeah. One. Two. 79.
79 is the seventh data point.
Yeah. One. Two. 80.
80 is the
last one,
eighth one, yeah?
Yeah.
Okay, cool. So you have those all in the video.
Once you do that,
Remove the flask from the sand, so the heat is being removed.
Just lower the jack.
Okay.
Turn that off. One plug.
And we unplug. So we got the
And you
data.
let that cool. And this one,
We're keeping the initial sample on ice.
yeah,
S1, which was the simple distillation data, which has the mixture of compounds to see how well the separation occurred. Alright, so it's still hot, but we're carefully taking off the round bottom and put in the beaker. It's still it's still cooling down, but it's okay.
And then
Disassemble.
and that's it. And now,
Yeah.
with that, you are going to the hood and make what is called a fractionating column.
So you're going to turn the simple column into a fractionating column.
Yeah.
Alright, yeah. So you're adding some steel wool.
Yeah.
Chop it up. So you're going to make an improvised fractionating column.
Yeah. That's the right word.
To see if fractionating helps in the separation process. To see if the two esters get separated better by having this kind of metal matrix inside.
That's good.
See it?
That's a fractionating column.
So now you have all this metal steel wool And then you'll see, hopefully, that the separation occurs better because all this helps with the separating the two vapors, I guess, yeah? Okay, cool.
No, I need to get the F1 vial.
Need to get the S1 vial.
F1.
F1.
You need to add F1.
Yeah.
We need to add 1 minute of diethyl ether.
The F1, and you're going to put the diethyl ether in there.
Yeah.
Just like you did before for S1. So now you have 1 milliliter of diethyl ether in the vial F1, just like you had 1 milliliter earlier of S1.
Yes.
Okay, cool. All right.
Here, it's not a Vigo colon, but it is a fractionating colon.
So it's not a fancy, it's like an improvised
one.
fractionating column. So now it's going to be the second experiment.
Yeah. And what does the metal inside the micro air condenser do? So the metal inside the micro air condenser does allow the formation of multiple cycles of vaporization, condensation, vaporization, condensation, vaporization, condensation. Remember that when you perform a simple distillation, you only have one cycle of vaporization, condensation. Okay, but so you have something like that. That's boiling point of A.
Boiling point of A over there? BPA?
Yeah, I'm going to put that over here. Boiling point of A. And here, boiling point B, that's the boiling point.
You have boiling point of A on the left, boiling point of B on the right.
Yeah.
Got it.
And that. Okay. Here is the temperature, which I put like that, temperature. Here is the more friction, so let's say 100% of A, 50%, 0% of A, 100% of B, 50%, and 0%. Let's say I put A here, 100%, and that, and here B, and here B, 0%.
So on the left is 100% A, 0% B.
Yeah. Okay. That's A and that's B here. Yeah. Boiling point. So, let's see, that's the temperature. Let's take a mixture like that. Here, that's the liquid. And here, that's the vapor. If you take a mixture here, so you have, when you go for simple distillation, you just have one cycle of, I will call that here, K, P, and here I will call that Z, for example. So KP is a tie line, it's an horizontal line, and it means vaporization line. And here is a condensation line. And you see what you collect here, that's where you collect. Collect here. And what you collect here, as you can see, you don't have a good separation.
No.
Because you just have one cycle of vaporization, condensation.
Yeah. That's simple distillation.
Simple distillation.
Yeah.
Fractional is a little, let me do that. Don't take it. Now if you take a mixture from here,
so this is fractional distillation.
Fractional distillation, you see that you have multiple cycles of vaporization condensation. That's the first, here is the first vaporization line, condensation, then next vaporization line, condensation, then the next one, condensation, until you have a good separation. And all of that is possible because of a fractionating column.
So it just causes these equilibration events,
Yeah.
and eventually just gives you better separation.
Yeah, and it gives you multiple cycle of vaporization, condensation, vaporization, condensation, vaporization, condensation, until you have something.
Yeah.
When you have a simple distillation, you just have one cycle of vaporization, condensation.
Yep. And you get often a mixture of compounds.
Yeah.
It's not pure.
You see here, that's about
Like
75% of
75.
A and something like 25% of B. That's the mixture you have.
Okay. Cool. Whereas this technique gives you a more likely a full separation of
Yeah.
100%
That's
A,
right, yeah.
A, or close to 100% A.
Yeah.
Okay. So you're setting up the fractional distillation apparatus the
Yeah.
same way. You
Same
clamp
way I
in
did.
the condenser. You have the thermometer up there, and you got some new of the mixture.
Yeah,
ethyl acetate, propionate.
That's the mixture, yeah.
So prepped it the same way, except now you have the fractional column in there with the steel wool,
Yeah.
and then you have your sand bath. You plug everything in. Backwards.
I just cannot see.
I got it.
Yeah. So you.
Okay, so
So
now,
hit that one. So as you can see, I don't see. I need to go outside. Yeah, it's too blurry.
alright, wipe those goggles off.
Yeah. One of my students did teach me to do that, and
So it helps you with the fogging.
he said me
Put
with
a
fogging.
little paper towel and the goggles
Yeah.
trick. I've never
And
heard
that
of
was one of my students who did teach me
Yeah.
how to do that.
that. Okay.
So now it's
So we got it going. I turned it up a little bit initially,
yeah.
just to
Start
speed up
to
the
work, yeah.
process. We see it's boiling already. Same thing's going to happen. It's going to boil up from the round bottom through the fractioning column, through all the metal pieces of wool, and eventually come out the top. And then we'll do the same thing with the data collection and the.
Yeah.
We'll capture the first drop into the vial,
Yeah.
and then we'll get a number of data points for plotting the data later. But meanwhile, we're just waiting for it to heat up, and we'll probably take a pause on the video while it's climbing up.
Yeah.
Okay, so this is progress report. This is actually going a little faster than the other one. It's pretty hot already at the bottom, and we're going to speed it up.
Yeah.
Some glass wool to keep the heat in, and then we're going to watch the temperature go up and be ready to listen for the numbers as they come off. Do we have an increase in temperature yet?
Yeah, I did.
I mean on the thermometer?
No, not yet.
So we're looking at the thermometer. It looks like it's about 20 something. It's not nothing yet, but it's going to climb up pretty quickly.
Yeah.
Looking at the data, and so there's our little nozzle for the collection, and what's the temperature now?
So it's not going up yet, but it's going up slowly. It's going slowly here.
Okay.
Now it starts to go slowly.
Yeah, okay, so we're almost there. Almost there. Okay, so we're heating up, and we feel the temperature climbing now, and you see the temperature climbing. So we're at what, 40, 50 degrees, and you have your container ready to capture it for the analysis. Temperature is where?
First drop is in.
Okay, so we got our first drop in.
At 58.
68 degrees is the first data point.
No, 58.
5.8?
Yeah.
First data point's 5.8. So we put that in the ice. First data point is 58 degrees Celsius. Now we're just capturing more. Every
260.
So data point 2 is 60 degrees Celsius. Data point 2 is 60.
64.
Okay, so data point 3 is 64 degrees Celsius. 64.
66.
Data point 4 is 66 degrees Celsius. Data point 4 is 66 degrees Celsius.
269.
Data point 5 is 69 degrees Celsius. 69 degrees Celsius. Data point 5.
271.
So data point 6 now is 71 degrees Celsius.
79. That's 71. Yeah.
71. So data point 6 is 71.
73.
Data point 7 is 73 degrees Celsius.
Yeah.
73.
To 74.
Data point 8 is 74 degrees Celsius.
Yeah.
74 degrees Celsius. Cool. So we have all 8 data points. Yeah.
Yeah.
And we're done.
We're done. Yeah.
Okay, so you're just gonna get the heat off, unjack it.
So like that.
Remove the heat. Turn off the regulator and unplug.
Yeah. Unplug. That's the first thing to do.
Okay. And then disassemble.
Disassemble. Still too hot, but
Still boiling. It'll cool down quickly. The analysis samples S1 and F1 are in the ice.
Yeah.
Put the glass wool back in the jar
Yeah.
for the stock room.
Yes.
And that'll cool down.
As you have seen, we did first perform a simple distillation, and you collected 8 data. And after that, we did perform a fractional distillation using a fractionating column, and you also did collect 8 data.
So you have 8 data points for simple, you have 8 data points for fractional.
Fractional.
They're
And
all-
what you
they're
do
all-
is that you have to graph temperature versus drop.
Okay, and you'll see the curve of temperature for as the distillation progresses
Yes.
in simple and also in fractional.
Fraction. Yeah.
Okay.
And I need to see that in your lab report.
So you'll put the graphs in your lab report.
Yeah, the 2 graphs.
And all the data is in the video, so you have to get it from the video because
Yes.
we didn't write it down. It's
Yeah.
all in the video.
Yes.
Okay. And you did your you disassemble. It's cooling down. Everything's cooling down.
So you cannot pour that into the organic waste bottle. It's still too hot.
Yeah.
Okay, that needs to be cooled to room temperature.
So you're gonna let it cool down before you pour it into the waste.
I cannot leave that here on the bench.
Yeah.
I need to put that in the hood.
It smells a little fruity, kind of a weird chemical fruity smell.
Yeah. But that it does not go back to the original container. That has to be poured into the organic waste bottle. The organic waste bottle you have here. And you pour in that, and that's how you do that.
You put the ether, the extra ether, back into the organic waste.
Yeah. And you cannot put the mixture of ch234 because it's still too hot.
So you're going to wait for it to cool down, and then you're going to pour it in the
Pour
same,
it there,
same
yes.
place, organic waste.
Yes.
Take 5 minutes or so.
Yeah.
And it makes a noise when it's
it's
the
nice,
airflow. So you got to drop this into the.
But you don't have that in your research lab downstairs, huh?
I turn
This
it off.
program.
I turn
Ah, okay, good.
Okay. All right.
So, when you perform a distillation, you have to be patient. You see how much time Dr. Anderson and I we took, okay, to have these 2 distillation done. Okay, and I think that you understood why we did use the fractionating column
You get a better separation.
to get a better separation. That's the type of things you need to know for the exam.
That's due to a lot of the equilibrating events between
Yes.
vapor and liquid, and that helps in the separation ability.
Yeah.